Question 7. An elastic cord was fixed between the end of an air track and a glider. The glider was pulled to the right, giving the elastic cord an extension delta x as shown. The glider was released and it moved to the left. A light gauge was used to measure the maximum velocity of the glider. This was repeated for different values of delta x. A student obtained the following results. As you can see, the results are plotted in the form of a graph, and the graph is plotted for velocity versus extension delta x. The question is, the principle of conservation of energy predicts that the graph should be a straight line through the origin. For the range of values of delta x used, the elastic cord obeyed Hooke's law. The question is, explain this prediction. You can see here, this question has 4 points, and to be honest, you don't know where to start, right? So I've explained this trick before. What you have to do is you should always look for keywords in the problem statement. That will give you a hint where you should start. So if you read the question again, it says the principle of conservation of energy predicts that the graph should be a straight line. So this principle of conservation of energy is a key word, right? So that's a good starting point. We'll just write conservation of energy. For elastic cord, in our case, potential energy must convert into kinetic energy. This is principle of conservation of energy for this cord and glider system. Using this principle, what we have to prove is this prediction that the graph should be a straight line. Now, how can you translate this word straight line in some form of an equation? So we know that for a straight line, whatever you have on the y-axis must be proportional to whatever you are plotting on the x-axis, right? If y is proportional to x, then we know that we'll get a straight line. So on y-axis we have velocity, and on the x-axis we have extension x. So now we have translated this keyword straight line into a mathematical equation. There is also a second method, a second way in which you can translate the word straight line in a mathematical equation. So we know that for a straight line, the slope of a straight line is always constant, right? So how can we find slope? We know that a slope is change in y divided by change in x. In our case, on the y-axis, we have velocity. So we can write change in velocity divided by change in extension delta x. If this is a constant, which means that slope is constant, then also we will get a straight line. Now, our principle of conservation of energy, so potential energy, we know that it will be the elastic potential energy stored in the spring or the cord. So we can write elastic potential energy, which is 1/2 k delta x squared. And kinetic energy, we know that it's 1/2 m v squared. Now, even at this point, if you cancel 1/2, you can see that k, which is a spring constant, it is constant. Mass is also constant, it is not changing. So you can see that velocity is proportional to the extension. But if you want to write it in a more organized manner, what you can do is you can find the slope, which means you need to find v divided by x. So I'll move this delta x on the other side. I'll get k over m equals v square divided by delta x squared. Now, if I take square root on both sides, I will get v over delta x equals square root of k over m. Now, we have already established that v over delta x is actually slope, and if slope is a constant, then it automatically proves that the graph will be a straight line. And you can see here that v over delta x, which is the slope, is a constant because k is a constant and m is a constant, so their ratio will also be a constant. The second question is, determine the stiffness k of the elastic cord. Mass of the glider is 300 grams. So we have already established that slope of this line will give us square root of k over m. So this is equal to slope, which is just change in y divided by change in x. So I hope that you can easily arrange this equation for k, but if you don't know, I will do it here. You just need to find the slope. You square it. That on the right side, this, when you take the square, it will cancel the square root, and then you rearrange this equation for k. So you'll get k equals slope squared times mass. But remember that mass should be converted into kilograms first. It is given in grams. It will be 0.3 kilograms. And for slope, I hope you know how to find the slope of this line. It is simply change in y divided by change in x. So you choose any 2 points on the on this line, and for these 2 points, you find the change in y, and then you divide it by the change in x. The last question is, when the glider was moved to the right by more than 0.5 meters, the graph began to curve. Explain why the shape of the graph changed. The answer is that beyond 0.5 meters, the cord was no longer obeying Hooke's law, which means that stress being proportional to strain, which is the condition for Hooke's law, this is no longer valid beyond 0.5 meters. That's why you will not get a straight line and you will get a curved line.